Hi friends, this is Mahesh. Welcome to Learn Networks. Today we are going to see about VXLAN lab. So before that, we just can have a short description about what is VXLAN, why do we use VXLAN. So the VXLAN is a L2 DCI or the L3 infrastructure. DCI in other ways called data center interconnect. Similar to OTV, VXLAN is also used to extend the L2 network of the LAN or the L3 network of the WAN. But VXLAN has got advantages compared to OTV2. So VXLAN is an open standard. We can deploy the VXLAN on multiple vendors like Cisco, Arista, and Juniper. And VXLAN is L3 independent, which means we can use any underlying layer 3 protocol to interconnect multiple DCs and extend L2 between them. It provides the multi-tenancy environment and share the same VLAN IDs for multiple clients and can be extended via the VXLAN overlay, still segregating the traffic between them on the L3. VXLAN is also known as MAC in IP to in UDP protocol. Regular layer 2 frames which will be encapsulated with these three different headers in terms of VXLAN plus IP plus UDP. So we have few terminologies used in the VXLAN lab. So probably I can say in that way. VTEP. VTEP is a VXLAN tunnel endpoint, which is configured on the leaf switches, the devices on which the VXLAN is configured. Yeah, VTEP is will be responsible for encapsulate and decapsulate the VXLAN header and VNID. So the VNID is otherwise called VXLAN identifier. Same like VLAN ID, we would say the VNID. So this is the unique ID assigned to every VLAN which gets extended over the VXLAN network. When the layer 2 frame reaches to the VTEP will replace the regular VLAN ID with the corresponding VXLAN ID, which will help distinguish between the layer 2 networks. And VN segment. VN segment is the layer 2 overlay bridge created between the VTEPs to extend the layer 2 to layer 3 via VXLAN. And we have NV interface. So the NV interface, this is a logical interface created inside the VTEP which used to map the VNA with a multicache group address. And so how let us see how the MAC learning happens in the VXLAN. So there are three types of deployments. One is Ingress replication, the other one is flood and learn, and the other one is BGP EVPN. So in the Ingress replication, we do a we define the VTEP address statically, and in the flood and learn, we use the multicache to flood the ARP request and get the ARP reply, and in the BGP VPN, we use the BGP as the control plane for the overlay traffic. Let's say the actually BGP VPN learns the MAC address between the leaves and advertise it to the other leaf. This is how the uh, it works. This is how the MAC learning works. So let us see how the MAC learning works in the real time lab. So right now I have two spines and two leaf switches. Let me log into spine 1, and you can go through the blog.networks.co.in for more informations about the VXLAN. I'll be keep updating them based on your feedback. Still, if you don't understand, I can keep update them. So we have a spine and leaf where the spines and leaves are connected over these interfaces E1/1 and 2 and 1/3 and 4 on the leaf switches. So this is connected over the L3 interface. This has been all the things have been configured, pre-configured. Let's say show IP interface brief, and you can see all were configured and configured with OSPF. You must be having a two OSPF neighbor on each spine and leaves. Yep. So now let's first do the let's open this PC. We have two PCs here connected to the leaf switch. So here let me assign the IP address for this PC 171.21.140.10/24, as well as here let me assign 171.21.140.20/24. So right now we are going to have these PCs on VLAN 140 on the both the leaf switches. Let's say show run interface Ethernet 1/1. So this is on the VLAN 140, and in leaf 2 show run interface Ethernet 1/1. This is also on the VLAN 140. Now can we let's see the upstream interface show run interface Ethernet 1/2 and 1/3. These are the L3 interface. We don't have these VLANs allowed in. We don't have any L2 links between the spine and leaf. So it's all going to be L3 and running OSPF on them. So let's try to ping 171.21.140.20. We should not be able to ping. And so now let us start the configuration. What are the features required to be done on the spine switches? So go to config T, enable the feature fabric forwarding. This helps to forward the encapsulated packet over the spine switches. Config T, feature fabric forwarding. Then let's go to leaf switch, config T, feature VNID segment based VLAN. This is used for VXLAN to VN feature VNI segment VN segment VLAN based. This is used for VXLAN to VLAN mapping. Then feature NV overlay. So this is the NV tunnel which we use to create feature NV overlay. So now let's start. Let's now in the leaf switch, let's create a NV interface and first create a VLAN and do the VLAN to VNA mapping. VLAN 140. So this is a VLAN we assigned for the client, and create VN segment 50140 and come out of this. Let's get into the leaf 2 switch, config T, VLAN 140, VN segment, I'm sorry, yep, VN segment 50140. So you need not to have the VLANs to be same across all the leaf switches. We can use any VLAN we wish, but the VN segment, whatever the VN segment you map it, that matters now. So the VN segment, the VN ID should be the same between the leaf switches. The VLAN can be anything, because on the encapsulated packet we are going to carry the VN ID rather than the VLAN. So now create the NV interface NV1. So the NV interface is a logical interface which helps to encapsulate this VXLAN in the NV1. So now source interface loopback 0. Yep. So let's configure VN, sorry, member VNI, the VN 150140, and what we are going to do is Ingress replication protocol static. So the difference here is like we are going to mention statically about the other VTEP devices. Let's say what is the IP address of this loopback on leaf 2 is going to be configured over this particular interface, peer IP. So now let's jump into this particular interface, the source interface loopback 0, VNI, sorry, member VNI 50140 and Ingress replication protocol static. So now let's configure the peer IP 192.168.0.3. So now let's try to ping from VPC1 to VPC2. Okay, let's see what happens. What is missing between it? So let's check the reachability. Source dot 3 as we are able to reach it. Okay guys, I think we need to have NV interface up. Show NV interface. Let's check the interface. Their state is down. Show NV interface. I'm sorry, interface. Let's NVE1 no shut config T interface NVE1 no shut. So NVE interface there up and show NVE interface it's up. So let's see. Yes, we are able to ping it. So let me explain what happens behind the scenes. So let's go here and capture the Ethernet 1/2. So I'm going to ping it and we should be able to see a packet. Let's capture 1/3 along with this. Yes, we are able to see the traffic. Let's stop the capture. So we are pinging from 171.21.140.10 to 20. So here, if you see the source MAC address and the destination MAC address is going to be the original MAC address, and it uses the source IP as the loopback 0 of the leaf 1 and the destination IP as loopback 0 of the leaf 2. So this is getting encapsulated over that. This is the outer header and this is going to be UDP port 4789 and this is a VXLAN local area network. And if you see the VN ID what we have configured 50140, the VLAN ID is never going to be travel via these particular ports. So and this is the inner traffic where it has the MAC address of the existing PCs and we can see the IP address, the source and destination IP address, which is on the inner header. So there are the two headers. One is going to be the outer header and the inner header. The outer header consists of the original leaf MAC addresses and original leaf IP addresses, and the inner header going to have the uh, VN, VLAN. They'd never carry the VLAN informations. They're going to be have only the original PC MAC address and the destination MAC address. So what happens to how the ARP request is being handled? So the moment we get the ARP request, so the leaf switch is going to receive it and they are going to send it to all the leaf switches via the unicast IP address. Let's say we have configured since we have configured the, let's say, show run interface NV1. So since we have configured the peer IP address statically, this is going to be sent as a unicast. In a larger environment, we cannot keep adding the peer IP in each and every leaf. So let's say we have 100 leaf switches within a data center. So we cannot keep configuring the 100 leaf switches on 100 devices, which is going to be a huge task. So to overcome this, we have got a flood and learn. So in a traditional VLAN environment, the flood and learn in the sense it's going to be broadcasted to across all the devices and learn them. However, in VXLAN environment, it's going to be it's going to be multicast environment. So for each and every VXLAN, we are going to assign one multicast group, and it's going to be sent to the broadcast traffic from the traditional broadcast traffic is going to be forwarded as a multicast to all the VTubs, and the VTubs again going to receive the uh, Glib switch is going to receive the ARP reply as the unicast. So let's have this by next class. Thank you very much. Thanks for watching.